Okay, today we're looking at the volume review worksheet, and this is page 1. So the first thing is to calculate the volume of each rectangular prism, correct to one decimal place if necessary. So the volume formula of any prism is V equals AH, where the A equals the area and H equals the height. So for a rectangular prism, we have that the area of the rectangular prism, or the area of a rectangle, or the base of the rectangle, is L times B. So instead of that A in here, we are going to write LB, and then we have our H on the end. That is our formula for the volume of each rectangular prism that we're going to use here. So we'll have V equals LBH, where V equals our length, which is 18, our breadth, which is 12, and our height of 9. So V will equal 18 times 12 times 9. So V equals 18 times 12 times 9, which is 1,944 centimeters squared. For B, we have volume equals LBH, where our length is 7.4, our breadth is 2.8, and our H is 1.3. So volume equals 7.4 times 2.8 times 1.3. Put that into your calculator. So 7.4 times 2.8 times 1.3 gives us an answer of V equals 26.936, and we're rounding to one decimal place, so volume equals 26.9. This is meters squared. Oh, and one thing I have done wrong already is that this is meters and centimeters cubed, so volume is always in the units, is always units cubed. Good pick up. So for C, we have volume equals LBH, and in this one we have our length to be 20, our breadth is also 20, and our height is 35. So it will be volume equals 20 times 20 times 35. So volume equals 20 times 20 times 35, which is 14,000 centimeters cubed. For our last one, we have that our length is 24, our breadth is 8.3, and our height is 9.5. So we'll have volume equals LBH, volume equals 24 times 8.3 times 9.5. So volume equals 24 times 8.3 times 9.5 is 1,892.4 meters cubed. To calculate the volume of each triangular prism, give your answer correct to two significant figures. So for the volume of a triangular prism, we use the formula V equals AH, where our A stands for the area of a triangle, so a half BH, and we're going to change the height to length, so how long it is away from the triangle, or how high. So we have the formula V equals a half BHL. So we have our height of our triangle, our base of our triangle, and our length. So volume will equal a half times 7.8 times 9.2 times 3. So volume equals a half times 7.8 times 9.2 times 3, which is 107.64. Now to round to two significant figures, our first two significant figures is the 1 and the 0, but because this 7 is greater than 5, this will round to 110 centimeters cubed. We just ignore our decimals. Okay, so now we have our volume formula, so a half BHL, where our base is 1.8, our height is 1.2, and our length going back from our triangle is 2.1. So we'll have volume equals a half times 1.8 times 1.2 times 2.1. So a half times 1.8 times 1.2 times 2.1. gives us a volume of 2.268. Now, to two significant figures is the 2 and the 2, but this 6 will round up that last 2 to be a 3. So it'll be volume equals 2.3 meters cubed. For our last one, we have volume equals a half BHL, where our base is 32.6, our height of our triangle is 15.7, and our length going back from our triangle is 49.1. So we'll have B equals a half times 32.6 times 15.7 times 49.1. So a half times 32.6 times 15.7 times 49.1 gives us an answer of volume equals 12,565.181. Now, two significant figures is just the 1 and the 2. However, the 5 rounds up the 2 to be a 3. So volume equals 1, 3. And then we make all our other digits 0 centimeters cubed. For question 3, we need to use Pythagoras' theorem to find the height of each triangle. Then calculate the volume of each triangular prism to the nearest cubic centimetre. Now, there probably isn't enough room on here to do all of this, but that is okay. So we know that this side here is 13 centimetres, as it is the same as this length here. And what we're trying to find is the height or base of this triangle. So to use Pythagoras' theorem is c squared equals a squared plus b squared when we're finding the hypotenuse. But we aren't finding the hypotenuse here, we're finding a shorter side. So we use a squared equals c squared minus b squared. So for this, we will have our unknown I'm going to call x. So we'll have x squared equals 13 squared minus 5 squared. So x squared equals 13 squared minus 5 squared, which is 144. So then x will equal the square root of 144. So x equals 12 centimetres. So our height there is 12 centimetres. We then use our volume. And so we're using the same formula as before to find the volume of the triangular prism. We'll use V equals a half BHL. So a half BH is our area formula for our triangle, and then our length going back. So we have our, this is technically our height of our triangle, our base, and then our length. It doesn't really matter. We just need to make sure that we're using the correct numbers for our triangle. The reason why we use these 3 numbers and we don't use the 13 is because we want to know how far back from the triangle the distance going back from the triangle is. So we want to know this distance. This distance is just irrelevant to us. It was helpful to find our unknown. So we'll go a half times our b of 5 times our height of 12 times our length of 9. So a half times 5 times 12 times 9 gives us a volume of 270 centimeters cubed. Okay, for this one we have that we are trying to find this unknown here, and again it is a shorter side because our hypotenuse is at 25.4 because it's opposite the right angle. So we're going to call this length x, and that is our height of our triangle. So we'll have x squared equals 25.4 squared minus 15.2 squared. So x squared equals 25.4 squared minus 15.2 squared, which is 414.12. What we then do is to get x is we square root that, so 414.12. To get x equals, and I'm going to just use this as, so we'll have 20.3. So the answer is 20.3499, but as the other lengths are all to 1 decimal place, we're just going to use x to 1 decimal place. So then volume equals a half times, now that is one of our dimensions that we want. That is our height of our triangle. Our base is our 15.2 and our distance going back is our 71.6. So it'll be a half times, so base, height, length, times 15.2 times our 20.3 times our 71.6. So volume equals a half times 15.2 times 20.3 times 71.6, which equals 11,046.448, and to the nearest cubic centimetre is just 11,046 centimetres cubed. Finally, we want to find the height of this triangle, and so what we're trying to find is this bit here. So we know that this length here is 26, and what we actually have is that this length here is 10. So we have that in there is 10. So off to the side, I'm going to just draw a right angle triangle to, whoops, that is not straight, to show this. So what we have here is that this is 26, our unknown is here, which is our height, and then we have that this length here is 10 because it is exactly half of 20. So to find our h, it's the shorter side, so we use h squared equals our c squared, which is 26, minus 10 squared, so we get h squared equals 26 squared minus 10 squared is 576. So then we square root this to get h equals the square root of 576. So h equals 24. So that means our height is 24. We then need to work out what lengths we want to use. So we will want to use our height. We then want to use our base, and we want to use our length going back from our triangle, which is our 19. So they are the distances that we are going to use. So we will have volume equals a half times our base of 20, our height of 24, and our length of 19. So a half times 20 times 24 times 19 gives us a half times 20 times 24 times 19, 4,560 centimeters cubed. Okay, now we want to find the volume of each trapezoidal prism to the nearest square unit. So what we want to do for this is we use the formula V equals AH. So we still use V equals AH, but what we do is our area formula for our trapezoidal. So H on 2, bracket A plus B. So our volume formula for a trapezoidal prism is going to be H on 2, bracket A plus B, and then times that length again, going back, or the height. So we will have, if I label my first trapezoid, is we have our height of 2.1, we have our A value of 4.2, we have our base value of 6.4, and we have our length value of 3.5. So it'll be volume equals our 2.1 on 2, bracket our A value of 4.2 plus our B value of 6.4 times our length value of 3.5. So our volume will equal 2.1 on 2, bracket our 4.2 plus our 6.4 times our 3.5. And so we get volume equals 38.955, and it's to the nearest square unit, so volume will equal, we have to round up because of the 9, 39 meters cubed. Now for this one, what we have is we have our height is this distance here, which is 12. We have our A is 20, our base is 15, and our length going back is also 12. So we'll have the formula to be V equals 12 on 2, bracket our A value of 20 plus our B value of 15 times our length going back, which is 12. So V equals 12 on 2, bracket 20 plus 15 times by 12. which is 2,520 centimeters cubed. And lastly, we have our height to be our 6.5, which is this distance here. We have our A value to be our 7.1. Our B value is here, which is 2.2, and our length or our height of our solid is 5.8. So we have V equals our height of 6.5 over 2, bracket our A value of 7.1 plus our B value of 2.2 times our length of 5.8. So then our volume equals 6.5 on 2, bracket our 7.1 plus our 2.2 times our 5.8. So we get 175.305, and to the nearest square unit, volume equals 175